Good morning, students. So in our previous class we saw in our lesson 3 HCF and LCM about factors and about multiples. What do you mean by factors and multiples and its properties, and also prime numbers and composite numbers. Now we will see how we can find the prime numbers between 1 to 50. Okay, so there is one activity. That activity we will do. So for that, what you can do, you can take a paper. In that you can write 1 to 100 numbers, natural numbers. So if we have to find the prime numbers till 100, we can write the numbers till 100. If we have to find till 200, we can extend the numbers 200, 300, 400. So here I will show how we can find the prime numbers and the composite numbers till 50. Then you can use the same method and you can find till 100, 200, 300 also. So this method, it is known as C of erythesis. Okay, erythesis. So for that, first there are some steps. We need to follow those steps. Now we know 1 is not a prime number, it is not a composite. So we will remove this 1. Okay. Now 2 is a prime number. So we will circle it. And the multiples of 2, all those the multiples of 2 till 50 we have to cross. So first step is circle the first prime number, smallest prime number, and then cross out all the multiples of 2 till 50. So for 100 we can continue till 100, 200, 300 also cross. So here 4, 6, 8, 10, 12, 14, 16, 18, 20. So these all are the multiples of 2 till 50. Okay. Now this is first step. Now second step, we will circle 3 and say we will cross out the multiples of 6. Now 6 ones are 3 ones are 3, 3 twos are 6. 6 is already crossed. So we'll see the next. That is 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48. Okay. Now next step. Again we can see here one more prime number. That is 5. Same step you have to follow. Circle that next prime number, that is 5, and cross out the multiples of 5. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Okay. Now here till 1 digit here you can see only 1 is remaining. So that also we will circle and we will cross out the multiples of 7. 14, 21, 28, already they are crossed. 35, 40. Now here you can see that here some numbers are remaining. So whichever numbers are not crossed, those all numbers we will circle. Now these numbers here till 50, those numbers which are circled, all those numbers are prime numbers, and the numbers which are crossed out, all those numbers are composite numbers. Okay, so this is the method with which we can find out the prime numbers and composite numbers. Okay, so this is an activity. Okay, to find the prime and composite numbers. Now, before going to HCF and LCM, you should know the divisibility rules. To find the HCF and LCM, you should these divisibility rules are important. So, we are going to study now the divisibility rules. So, you are having divisibility rules till 10, 11. Okay. Some divisibility rules you have already studied in 5th standard. Okay. Now, first, what do you mean by divisibility rules? Why those are used? Okay. Now, what is divisible? Divisible means if any number is said to be divisible by another number, means when you divide it, you will get the remainder 0. Means leaving no remainder. That is, for example, if 4, we should know that we have to find that 4 is divisible by 2 or not. So if we divide it, if we are getting the remainder as 0. So this means that 4 is divisible by 2. Okay. Now for smaller numbers, directly we can divide and see. But for larger numbers, for lakhs, crores, millions and all, it is difficult to find out that that number is divisible or not. We have to sit and divide it. So long division method we have to follow. So to avoid that, we can use the shortcut method, that is HCF, and for HCF and LCM we need this. So that shortcut method is divisibility test. By using this test, by knowing this test, we can easily find out that that large number is divisible or not. Okay, so you are having the divisibility test for 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Okay, so let us see which those divisibility tests. Okay, so first we will see the divisibility test for 2. Now, divisibility test for 2 is a number is divisible by 2 if the digit in the ones place. In the ones place, if there is 0, 2, 4, 6, 8. Means if in ones place these digits are there, that means that full number is divisible by 2. If we take any example, now here this is 1472. Now this number, here you can see in ones place 2 is there. So here 2 is there. Any of the number digit is there. If your 0 is there, or if your 4 is there, or 6 is there, or 8 is there, any one digit is there, that means this full number is divisible by 2. No need to divide it. Directly you can tell that if in ones place these digits are there, it is divisible by 2. Okay. So this is divisibility by 2. Now next is divisibility by 3. So the divisibility by 3 is a number is divisible by 3 if the sum of the digits is divisible by 3. Means when you add the digits. Now for example, if here 315, this is a number. Now this number is there, we have to see it is divisible by 3 or not. So for that, what we have to do? We have to add the digits. 3 plus 1 plus 5. After adding, what we get? 6 plus 5. Here 3, 4 plus 5, 9. So 9 here. 9 will come in 3 table, it is divisible by 3. So this full 315, this full number is divisible by 3. Okay, we'll take any large number and add the digits. 18 is divisible by 3. It will come in 3 table. 18 is a multiple of 3. So that means this full number 1881 is divisible by 3. Okay, so this is divisibility of 3. Now next is divisibility by 4. Divisibility by 4 is a number is divisible by 4 if the number formed by the last two digits, means ones and tens place, whichever number is there, that should be divisible by 4. Means, for example, now this is one number 63,784. Now you can see here 84. So 84 is divisible by 4 or not? 2 digits. So ones and tens place. If this 84 is divisible by 4, that means this full number is divisible by 4. So we can tell directly 4 2s are 8 and 4 1s are 4. It is divisible. We will get remainder 0. That means this full number, when we divide and see, we will get the remainder 0. So this is divisibility by 4. Okay. Now next is divisibility by 5. Divisibility by 5 is same like this 2. Only we have to see in the a number is divisible by 5 when in the ones place either there will be 0 or 5. Okay. If in the ones place, if 0 or 5 is there, any, now we know 5, 10, 15, 20. So here, ones place you can see the multiples of 5 in ones place we are having here 5, 0, 5, 0, 5, 0. So that means a number is divisible by 5 when in the ones place either 0 or either 5 is there. So that full number will be divisible by 5. Okay. Next is divisibility by 6. Divisibility by 6 is for a number should be divisible by 6. That number should be divisible by 2 also and 3 also. Which we know 6 is equal to 2 into 3. So, if a number is divisible by 2 also and it is divisible by 3 also, that means that number will be divisible by 6. If it is divisible by only 2, not with 3, then it is not divisible by 6. It should be divisible by 2 and 3 both. Okay. Next is divisibility by 7. Now, divisibility by 7, you have to understand carefully. Divisibility by, indivisibility by 5, a number is divisible by 7 if the difference between the last number, the twice of the last number and the remaining number is, the difference is either 0 or the multiple of 7. Means, if a number is given, if we'll take the ones place, here first digit, here 5, twice, they are telling twice, double. So 2 into 5 is 10. That 10 we should subtract with this. So 297 minus 10, that is 287. So if the difference is 0, if we get here 0 or it is multiple of 7, then now here you can see it is multiple of 7. When you divide it is divisible. 7 4s are 28 and 7 1s are 7. So when you divide it is divisible by 7. So this number is divisible by 7. Means what you have to do? First you have to take the ones place number, that you have to multiply with 2. When you multiply with 2, whatever number you are getting, that number should be subtracted with the remaining number. If you are again 2, 3 numbers are there, you should take all that. You have to subtract with that. And if we are getting this number should be either 0 or that should be divisible by 7. Okay? Or multiple of 7. This is divisibility by 7. Now divisibility by 8. Divisibility by 8 is same as 4. So for 4, we took 2 digit, last 2 digit, one sentence. For divisibility by 8, we have to take last 3 digits, ones, tens and hundreds. Next is divisibility by 9. Divisibility by 9 is same as 3. What we did for 3, we added the digits. Same method we have to follow for 9 also. We have to add the digits, and if we are getting the answer, after adding, if we are getting the answer as the multiple of 9, then it is divisible by 9. For example, now this is a number. If we add the digits, what we will get? So 27 is a multiple of 9? Yes, so that means this full number is divisible by 9. Now next is the divisibility rule for 10. 10 is same as 5. Means in 5 either it should be 0 or it should be 5. But for 10 we know the multiples of 10 are 10, 20, 30, 40. So if in ones place we are having 0. Any number, if in the ones place 0 is there, that means that full number is divisible by 10. Okay, so this is divisibility by 10. Now next is divisibility by 11. This is same as 7. It is little confusion. Here what you have to do? Any number, it is divisible by 11 if the difference between the alternate numbers, means leaving one number, or the difference between the even number digits and the odd digits, if the difference if the sum of the even and odd digits and their difference will come 0 or a multiple of 11. It is little confusion now. What you have to do? If I take a number example, this is a number 27,896. The even and sum of even and odd digits or the alternate digits. Now here 2, 8, leaving one digit, 2, 8, 6. So we have to add that 2, 8, 6. And the remaining 7 plus 9. If we add this, what we will get? Here 16, here also 16. After adding this, we have to subtract these both. So here we are getting 7. So after subtraction, if we will get 0 or we will get the multiple of 11, that is 11, 22, 33, 44. If we will get after subtraction such numbers, then that number will be divisible by 11. Okay, so all the divisibility rules are given in textbook. Just revise this. So these are all the divisibility rules are there, that is important for HCF and LCF. Thank you.